Welcome to this module of Professor Messer's free CompTIA Network Plus certification training course, the online training course that's flown in fresh from the coast. I'm James Messer, and in this module, we're going to talk all about binary math. Now, before you get too worried about that word math, I'll let you know this particular module is actually very easy to follow, and it's an important module because it's going to build on a lot of things that we need to know from a math perspective of how to calculate things in binary that we will use in subnetting. This comes from the N10-004 exam, section 1.4, where given a scenario, we need to evaluate the proper use of the following addressing technologies and addressing schemes, and we're going to talk specifically about how we'll use this binary math to do subnetting. So as we go through this module, remember that the basics of binary math is really quite simple. A bit is the very basics of binary, and a bit is either a 0 or 1. It's a single digit. It's either on or off. It's either hot or cold. It's either 0 or 1. There are not spaces in between this. There's no decimal places. There's one good thing about binary math right there. There's either a 0 in a place or 1 in a place. And we're going to build everything around binary as it's based on that single idea. When we put 8 bits together, we usually call that a byte. You'll also hear it referred to as an octet. An octet is the same thing as a byte. It's 8 bits all strung together. It's just that other types of computing systems, especially legacy computing systems, older mainframes and other systems, may use the term byte to mean something a little bit different. And so in our computing world with these Intel-based CPUs, we talk about octets as these 8 bits together. But as far as we're concerned, especially in this series of presentations and training materials, you can actually take the word byte and octet and almost use them interchangeably. One thing that's very important as we go through all of these sections on subnetting, there are about 4 different videos that we'll look at on binary math and subnetting. You'll need to know this binary to decimal conversion chart. In fact, the first thing you do when you sit down at your Network Plus exam, this will probably be one of the things you write down on the blank sheet of paper that they give you, is this chart right here. And all you have to remember is starting over here on the right side, put a 1 and then double it to 2. Put a 2 and then double it to 4, to 8, 16, 32, 64, and 128. And you could even keep going. You could go 256, 512, 1024 into the far left side of this screen. But when we talk about an octet, we're usually dealing with these 8 bits strung together. And this will probably take care of you in almost every situation as long as you write down this decimal conversion chart where you can take a binary number and convert it to decimal and back. You'll be just fine. And we'll go back to this chart again and again in these series of videos. One good way to learn binary math is to jump right into it. So I've created a problem here. What is binary 10000010 in decimal? Well, if you've never done any binary math before, you may be looking at that and wondering, how in the world am I going to convert these strange strings of ones and zeros into a decimal number that we human beings usually understand? We work in decimal every day. We rarely work in binary, but the conversion process is extremely easy. Here's what you're going to do. First, write down that binary number. Give a lot of space there because we're going to put some other things on the screen. And you can see I've taken that binary number, 10000010, just strung it all out there on the screen. Right on top of that, I'm going to put that conversion chart we created in the previous slide. There's our 1, 2, 4, 8, 16, 32, 64, and 128. And I've just put them right on top of each one of those bits. And we're going to draw a line right underneath that. And what I'm going to do is perform a few calculations here. We're really going to look and see every place that we happen to have one of these bits located. So if there's a 0 under a number, then we don't bring the number down. If there's a 1, then we'll put that number on the line below. So there was a 1 here next to the 2, so we'll put a 2 down here. All the rest of these are zeros until you get all the way down the beginning over here where the 128 is, so we'll put a 128 down here. And so we're left with this string of numbers all together, and all you do is add them up. So 128 plus 0 plus 0 plus 0 plus 0 plus 0 plus 2 plus 0, you add all those up, that one's pretty easy, and you get a 130. And guess what? You're doing binary math. It's really that simple. As long as you can use that same methodology with every binary number or conversion from decimal into binary, you're in really good shape. Let's do another one. This one I made it almost easier. What is binary 11111111 in decimal? And you'll see later on why that becomes a very important number for us. But we do the same thing. We put all of these ones down, these 8 ones we'll put on our screen here or on our piece of paper. We'll put our binary to decimal conversion chart right on top of it. And then every place we see a 1, we bring that number down and we add all of those numbers together. So in this case, every single one of these bits was a 1. So we're going to bring down every single one of these numbers and we're going to add them all up. And once we add each one of those, 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, the answer to that, if you do the math, is 255. Now that's a very important number when we get into doing subnets. All ones subnets is an important thing to keep in mind. It's nice that we can see, oh, that adds up to 255. That means between 0 and 255, there are 256 total representations of numbers in there from a decimal perspective. So we can come up with 256 ways to write these ones and zeros down to come up with a number on this side. And that's going to be an important thing as we go through understanding IP addresses and how to subnet those. We'll come back to this again and again. Well, let's reverse it. Let's do it from the other direction now. What is decimal 154 converted into binary? And it's almost the same process we did before, but we're going to work backwards in a way. We're still going to put down all the ones and zeros that we happen to use, except we don't know what those are yet. So we're going to leave those blank for now, but we still will use our binary to decimal conversion chart to do this. We'll draw our line, and underneath this, we aren't quite certain exactly how all of these add up to 154, but I bet if you're looking at this at this point, you're probably noticing that all we have to do is fill in some ones and zeros so that it all adds up to 154. It's exactly what we're going to do. And we're going to do this methodically. We'll start on the left side where this 128 is, and we'll ask, is 128 less than or equal to the number we're trying to get to, which is 154? Well, 128 is definitely less than 154, so we'll put a 1 right there, and we're going to bring down our 128. Now we'll move over to the next one, and we're going to figure out if 128 plus 64, because we already know we have a 128 in its place. The next one over, if we add 128 plus 64, and that happens to be 192, is those two numbers together less than or equal to 154? Well, 192 is definitely more than 154, so we know we can't use that bit that's under 64. We know that 128 plus 64 isn't going to work, so we'll put a 0 right there. Now we're going to take still we have 128 in our list of numbers here added up, 128 plus 0. If we add a 32 to that, 128 plus 32 is 160. Well, that's not less than or equal to 154, so another 0 goes in its place. Next one over, 128 plus 0 plus 0 plus 16 is 144, and 144 is less than or equal to 154. Aha, we'll put a 1 right there in that place, and we filled in another spot. Now we've got 128 plus 0 plus 0 plus 16, that is 144. If we add 8 to this, that's our next one over, that equals 152, and that is less than or equal to 154. We put a 1, so you can start to see the process. We just do this over and over and over again. 152 plus 4, that's 152 is the number we add across the bottom, and see if the 4 that in our next place over is less than or equal to the number we're trying to get to, and it is not, so we put a 0. And then I think this will be the last one, because if you take all these numbers, which is 152, and you add the next one, which is a 2, that happens to equal 154. So we know we're going to use a 1 there, and since we're already at 154, we know this last bit is not going to be used. We can just put a 0 in its place. Now the nice part about this is you can't get it wrong. If you add all of these things up together and then you backtrack and you check your work, if you take 128 plus 16 plus 8 plus 2, and you can check and make sure that it's equal to 154. You almost don't even have to go through that entire process of, is it less than or equal to? Is it less than or equal to? You can sort of start adding in the numbers in your head and see what it adds up to. You're only going to get one of these that will work. There's no other set of zeros and ones that you could put into this list that would equal 154. So either way you do it, you're going to come up with those numbers. And once you do 2 or 3 of those, you're going to be able to really take any decimal number between 0 and 255 and very easily create the binary representation of that. For what we've done so far, we've really been working with only 8 bits. We've been working with an octet. If you start with a smaller number of bits, you really only have a smaller number of choices that you can have. For instance, if there are 2 bits here, which means you have a 1s column and a 2s column, then you can really only have the numbers 0, 1, 2, or 3. If you've got 3 bits to work with, you can have a numbers between 0 and 7, 8 different settings there. If you have 4 bits, notice you can have a number between 0 and 15. And it goes up further. If you have 5 bits, 6 bits, 7 bits, or 8 bits available, you can have larger size decimal numbers. And of course, you can keep going, 9 bits and 10, 11, 12, and so far into the future there. This idea is the important piece, though, is that the more bits you have, the more options available to you. And when we work with subnetting, we may be taking some subnets and only using 2 bits of them and trying to figure out how many networks we can make out of that. And you can see if you only have 2 bits, you only have 4 possible iterations that you could make out of something like that. As you take this idea of having different sizes of bits, different bits available to you, and using them in subnetting, you'll start to see where you can start looking at the size of a network or the size of the number of devices that can sit on that network. And it's all based around the number of bits that you have available to you. Our review is already here. We've already learned everything we need to know about binary math. See, I told you it wasn't that hard. So let's go through a few questions and see if we know what we've learned here. First, how many bits are in a byte? And remember, I told you at the beginning, we know that a bit is a 1 or a 0, but a byte happens to be 8 of those put together. And again, we'll often refer to that as an octet. Now, we also have a question here of what is the binary equivalent of 238 decimal. So what we're going to do is take our 238, we'll put our decimal to binary conversion chart up. And if you'd like, you can even pause right here, work out all the math on a piece of paper, and then start it back up again and see if you got the right answer. And the answer of the binary equivalent of 238 decimal is 11101110. Hopefully you got that right. And if you take each one of those ones, 128 plus 64 plus 32 plus nothing in the 16 plus 8 plus 4 plus 2, that should all equal 238. Let's do one more. Let's take a binary number. What is 10010 converted to decimal? And the answer there is going to be 20. Notice here that I left off that last 0 here. There's really only 7 bits available. There doesn't have to be 8 bits to do a binary conversion. So what you want to do is if there's only 7, then that 128 that's usually out here on the end just isn't counted. You would count it up, and we can do it right here almost in our head. 1, 2, 4. So there's a 4, 8, 16. 16 plus 4 is 20. Therefore, there's our number in decimal, which is a 20. Well, hopefully that's given you everything you need to know about how to do binary math. And this was a very important module because we're going to use all of this binary math going forward as we learn more about subnetting. And hopefully now you've gone through that section 1.4 of your Network Plus exam and you know everything you need to know about understanding how to calculate some of those subnets. For more free Network Plus videos, to participate in our message boards, to send me a message, or much more, you can visit our website, freenetworkplus.com.